that we are based in, and we are representing this Nano Academic Technology, that is basically a Canadian company. This company will help you to boost your research in the field of crystal molecule devices and all those things. So let me introduce about our partner, that is called Nano Academic Technology. It is basically a Canadian company. Okay, it was started in 2008 by Dr. Hongo, Dr. Ju, Dr. Lee, originated from McGill University, Canada. Initially, this tool was developed for molecular quantum transport calculations. More than 10 12 years of development with enhanced material development features to the advanced digitalization modeling and techniques, including several unique features in the field of emerging quantum technology. So in India, many people are planning to work on quantum simulations. So company is also providing some spin qubit semiconductor quantum simulation device tool, that is called QTCAL. We'll discuss in the slide after that. So first session, I will show you the presentation PPT as well as the user interface of the software, that how you can model different kind of structure. In the second half, at from 2 to 4 p.m., you can also make the hands-on session, since the software is provided to you, license is already given to you, and we will also share you some resources after the training as well, like manual tutorials, videos, everything will be provided so that you will fully explore this capability of tool, how this tool can benefit for DFT, nanomaterial, nanodevice, supercapacitor, or other quantum transport calculations. So let me discuss about timeline of this NEGF DFT, how the journey was started. Basically, in 2001, this code DFT with NEGF quantum transport was patented in 2001 in McGill University by Dr. Taylors, and in 2002 it is supported by Northwestern universities. This was initially the code, and later on, after development, so much development, it was they have developed this Nano Academic Foundation in 2008, and commercially this tool was available to the market from 2009. That basically can theoretically, or by using simulation, it can predict your characteristics of nanoscale devices along with materials. So it is a background calculation engine. NanoDCAL is basically a background simulation engine that will run the theoretical equations, that will run the Boltzmann, Kuhn-Sam density functional theory, including the quantum transport calculations. So it is basically a simulation engine that will solve the equations theoretically and generate some output based on the theoretical predictions. What kind of property it can predict, what kind of material it can simulate. We will describe all those things in details today's sessions. Along with that, there is a device studio in 2016 that was launched, so that instead of writing the code, instead of writing the script of the time, you will have sophisticated user interface. That user interface will help you to build your structures very quickly, very easily. You can manipulate the structure parameters like lattice parameters, ABC, alpha, beta, gamma, rhombohedral, hexagonal, triclinic, all the lattice related parameter, including their superlattice structures, interface heterostructures, even making the device or applying voltage terminal, defining the theory, everything with the help of single device studio user interface will help you to build your structures very quickly, so that you will not have to write the code or write in the script. How it look like, everything will be explained. Just concentrate on the software, since the license is provided for 1 month durations. So you can definitely be helpful. It will be helpful for you after this training session. Even you require some technical help, we will be happy to provide you the training after next week or next to next week, whenever it is required. Recently, the company is going under development for plus version, where the Python related software, Python code development, NanoDCAL plus version is also going to develop. This NanoDCAL is written in MATLAB language. Now, let me discuss about this next slide, where we will talk about state of art, this NEGF DFT code. The NanoDCAL, that is stand for Nano DFT calculator. So it is a density functional theory. That is a method, that is a theory which can predict the characteristics based on the input parameter that will be provided by the users. This many of the professors works on experimental, but when you are working on experimentally, there may be a chance that your material may not be getting proper output, because the output is dependent on the input parameters. There is very heavy costlier materials. If you are going some fabrication or testing synthesize, then if you are not getting results, then your material is wasting. And you can also use this kind of simulation software before going to the experimental works. So theoretical simulation, if you will combinedly use the experimental with theoretical or only simulation work, you can also get published your paper quickly. So if it is a match with the experimental and simulation, that is more reliable results are. So this nanodecal will help you, that can works on non-equilibrium green function with density functional theory. This code is written in MATLAB and C language. So if you know about MATLAB, if you have a good installed MATLAB, that will also help you to visualize your output that will generate by the software in your MATLAB codes. So this is MATLAB and C combination, which is used in many of the hundreds of publication. I will show you the publication list after this presentation as well, so that you can go through where the publications are and how, in which journal, in which reputed journal the papers are published by using this tool. It is major focus on electronic and spin transports calculation, including the two-terminal IV characteristics, diodes, transistors, including the three-terminal gate dielectrics. So transistor FET devices, two-terminal devices, even material, spintronics, collinear, non-collinear, spin orbit couplings, all analysis can be performed, like density of states, projected density of state, local density of state, projected local density of state, band structure, complex band structure, thermal transport, phonon tool calculation. So phonon spectrum, phonon is related property, thermoelectric property calculations, everything can be done by using this nanodecal tools. As you can see, this is some screen of the paper where there is a graphene layer is there, where left and right side there is electrode are defined. So electrode, this is a two-terminal device where graphene seed and there may be some molecule. So we can define some doping. We can, let's suppose we have a single layer of graphene. We can take multiple layer also, single layer, mono layer, bi-layer, tri-layer. So multiple layer of a graphene. If you want to dope some particular layer material, so you can dope some particular atom in the seeds, and you can create some defect, some structural defects, or some rotation of particular single atom or multiple atom in your complete sheets. Or if you want to create some delete particular atom on particular complete sheets, then by creating the defect, how this characteristics can be changes, that study you can perform by using these tools. In a detail, we will go to the hands-on session, how it can be done. Even those who already have the software and it is installed, they can also perform in the second session. Even after beyond that, we can also help you out. It can perform the transport calculation, electronic structure calculation, molecular spintronics calculations. All these things can be performed, including the molecules, crystals, devices, materials, two terminal, three terminal, four terminal, up to six terminal, with flexible devices, including the photocurrent or photodiode can also be simulated. Photodetectors will also be possible to simulate for sensors applications. Now, in this slides, let me discuss what other kind of material, what other kind of devices that you can model and you can simulate it. So that you can see here, this is graphene molecule, single layer graphene, and there is one molecule is layer on the top. If you want to simulate that kind of structure, any layer it can be. As an example, we have taken graphene, but whatever any 2D material or any material, it is a full flexibility to you, where you can choose the library material from our library. We have a common database material bank. From there, zero dimensional, one dimensional, two dimensional, even three dimensional, insulator, conductor, metal, semiconductors, all materials are exist in our database. From that database, whatever material you want to simulate, that you can pick up during the modeling of the structures. So you can simulate molecule, graphene, and also you can create the surface, define that particular uh, crystal. You can create the surface structure where you can define the Miller indices, that HKL value. So you can define the plane 110 plane, 100 plane, 111 plane, 001 plane. So any surface plane can also be defined to, so HKL, that Miller indices, to define the surface structures. And then if you want to define some complex material, complex in the sense some uh, tetragonal, triclinic, rhombohedral, hexagonal, biclinics, or multiple combinations of lattice are options are there. So any combinations of two or more material that can be created with multiple repetition on x direction, y direction, z direction, whatever the direction you want to repeat particular single or multiple atoms. The repetitions can be done, including the movement on particular angles. So that kind of complex structure, even in you want to create some heterostructures. Heterostructure in the sense whenever there are two materials are there, that support silicon and germanium, and that material you want to align to each other. The interface in between this two material, if you want to mix it, like silicon or germanium, gold or aluminum, or whatever, gold or silver, any material you want to make heterostructures, that heterostructures interface property can also be do the studies, including the molecular devices, where there is some left metallic electrode, right there is metallic electrode, and there is molecule in between that junctions. So that kind of molecular electronics, molecular junction based device, two terminal you want to simulate, that will also be possible. Two-dimensional based devices, let's suppose MOS2 based material you want to take, and then you want to define some electrode, define some gate terminal, and then FET devices you want to simulate, graphene based, graphene nanoribbon, carbon nanotube, and many other topological insulator, and many more options will be there, including there is a carbon material, molecules options are there. You can create different kind of molecules. There is one molecular builders is there, sophisticated molecular builder where trivalent and different bonding between the atoms, that kind of molecules you want to create the chain of the molecule. So that's why single chain you want to define benzene, multiple options of benzene, you can create the multiple complex material and their heterostructures. So this is your all single platform where you can simulate the material as well as device based on density functional theory and non-equilibrium green functions. This is about modeling. Once you model the structures, the next session goes to the theory, the advanced tools, advanced building tools in the sense where you can build the structures properly. You can repeat in particular direction and define some electrode, define some biasing on the terminal, define and calculate the IV characteristics. You can also set up the parameters. Parameter in the sense DFT parameter, density functional theory parameter, where you can define some K point sampling, pseudopotentials, basis sets, electron temperature, sorry, pseudopotentials, basis sets, electron temperature, exchange correlation functions, and Hamiltonian iteration control parameters, minimum iteration, maximum iterations. So that user friendly setup calculator parameter are there. Structure is model as the wanted to create it. Whatever the desired shape of your structure you want to create in our user interface. Once you created the structure, then you have to set your theory parameter, NEGF parameter, and some DFT parameters, pseudopotential, exchange correlation, K point sampling, basis sets, electron temperature, Hamiltonian, and spin related parameters, collinear, general spin effect. These can also be defined. And once you define it, you can run the calculation and simulation will be run by our tool, and you can visualize. Our visualization interface is also there, where you can visualize your output, and you can also extract your data in text file or even in image format. A single platform where you can perform all these things. You can calculate various electronic material property, electronic structure calculator, optical property, thermal property, magnetic property, electron and thermal transport, electron phonon couplings. These are the material specific property. Apart from that, for the device level, you can calculate the IV calculation, current voltage characteristics, transmission coefficient, thermoelectric, jet T, CV coefficient, and some modulars that will also be explained. Once you will explore the tool, then you will get to know there are so lot of things are present in the tools. So just keep patience, try to concentrate in, and you will feel how this tool can help you to complete your masters, BTech or MTech or PhD, postdoc, or even for the assistant professor or professor level. It will help you to boost your in your nanotechnology research, including semiconductor, nanoscale semiconductor devices. So this tool is basically for nano level, atomistics, nano structure, material and device simulations, not a layer structure. Micro level is the now people are moving to the atomistics from micro level. Centaurus, Silvaco may be working on layered weight structure, but here you will perform an atomistics calculations, atomic based junctions, atomic based layer structures can be created. This NanoDCAL can also work on Spintronics application. Let's suppose there even graphene seeds. If you want to include some movement of your atom, some spin effect you want to include it, then this Spintronics for next generation lower power consumption, this device can be useful for higher density analysis to increase the performance of your nanoelectronics devices. In this case, this spin effect can also be included. Some photons, you can put the light of your photons that can also put on your particular region on your particular device. Let's suppose there is single device, left side, right side electrode. You want to put the light, you want to fall the light on your middle region of your junction. That you can also perform the photons, you can absorb, and you can calculate the photocurrents. So spin polarization, spin movement, spin up, spin down calculations, and some spin transports calculations can also be performed. You can simulate single layer of graphene, armchair, zigzag, armchair, magnetic effect, magnetic property, atomic texture, magnet per atom property calculations. All these things, as you can see here, that can also be helpful to create such devices, including the photogalvanic devices. This tool can also help you. Like you have a multiple layers. It can be any layer. It can be a graphene, it can be a boron nitride, or it can be a MOS2, or it can be any material, whatever you can think at periodic table. That periodic table will also be there in the software, where you can choose the particular material from our periodic table. So that periodic table, once you select a particular material, then you can repeat multiple times in x direction, y direction, z direction, and you can also make the uh, tri-layers. So in this particular case, you can see there are boron nitride, Bn is called boron nitride on top side and bottom sides. So boron nitride on top, boron nitride on bottom, and there is graphene layer in this yellow color, which is sandwich in between the top boron nitride and boron nitride layers. So by making three layers, how this device left and right electrode are specified, and why this, what will be the, once you will apply on the voltage, then what will be the IV characteristics that study, and some other device property can be calculated, including the magnetic movement of particular age. You can also see the boron nitride to shift between different energy state, total energy, the total energy of the particular device, and nanoribbon, graphene nanoribbon, or armchair, zigzag, armchair, different chiral vector, n and m value of particular layer you can define as per the convenient. So you can see here, this is a band structure. So spin up, spin down in blue and red color. You can find the how much is the band gap in between the valence band and conduction band. So conduction band, valence band with the Fermi label, it will be plotted by the software, and you can find how much is the direct band gap, how much is the indirect band gap, and with all spin related features is already there. So this is all about that. It will also be possible, including it can works on molecular junctions, molecular electronics application. Let's suppose you have a metallic electrode on the left side of the terminal, right side of the terminal. In between, in the channel region, in the junction region, there is a molecule is there. Instead of crystal, there is a benzene molecule or any ethanoline molecules or whatever the molecules are there. So you can define the molecule in the middle regions, left, right. You can define the electrode, that is source and drain on the left side, and gate terminal on the middle sides. So you can see here, this is a left side, which is left electrode, metallic electrode, where this gray color something like it is there, that is called electrode. This green green layer is there, that is called one molecular layers, green layer. And this is a gate electrode where we can apply different vising, zero vising, 0. 0.1, 0. 0.2, 0.3, 0.4, as per our convenient, different vising on the gate electrode, and we can plot the transconductance, IDVD characteristics for the three terminal device can also be plotted. So two terminal, three terminal, including source drain, as you can see in graph A and B. This is a two different molecule. Molecular builder is also there. Whatever kind of molecule you want to create, you will have the complete option where the desired molecule can be created by you. And once this molecule is created, you can align the electrode. This electrode is aligned and connected with this molecule, and based on this transmission spectrum is calculated. So what will be the effect of particular molecule if you are changing the one molecule to another molecule? Then either the transport properties are changing, or what will be the effect? That kind of research can be done as by you. It may be under your curriculums that can be performed by you for doing such kind of research. Now, in the next slides, let's go to the toward the graphene electronics applications. As you know, there are so many people are working on 2D material. It could be WSA2, it could be MOS2, it could be graphene, or any other 2D material. So you can take the graphene that is already under studies. So let's suppose this is one uh, when graphene layers is there. Okay, you can find the simulate this graphene structures. PDOS, projected density of states with different brilliance zones, root band structures. This is band structure with gamma, N, M, N cross. So different brilliant zones root points are there. By that particular brilliant zones root point, the user can define their brilliant zones root point to find the band structures, to find the Fermi EK diagrams. So EK diagram, this brilliant zones can be plotted. You can define the specific points. You will have the full flexibility where the Boolean zones root point options like gamma, n, m, g, sigma, you can select at particular points, at particular coordinate points, and then you can plot your band structure. Then you can also plot your density of states. So you can plot this direct band gap, indirect band gap, and find the stability of your seats. It is also possible to define the synthesize on different surfaces. Like you want to simulate the graphene sheet on particular surface plane. So different 100 possible substrate, 11 possible substrate, find the lattice mismatching, adsorption, and covalently unbounded things. Like you can see here, this is one layer, and then another MOS2 layer you can create it, and band structure and other characteristics are plotted with different one 1D plot, 2D plot, three-dimensional plot. All these things can be plotted. Now let me go to the next slide, that is basically concentrate on mesoscopic electron transports in twisted bilayer graphenes. Let's suppose you want to do some innovative research. You don't want to do the research on planar graphene layers. You want to include some twisting. You want to make flexible structures. You want to rotate on particular angle, 20-degree angle, 30-degree angle, 50-degree angle, 70-degree angle, the angle whatever you want to create the twist, either left side of the electrode, right side of the electrode. So flexible seats you want to create, then this twisting the layer on particular angle, that can also be created. So you can see here, this is middle regions are there on CNT, and here you can see here, this is left side and right side are twisted on few degree angles, and based on that, graph A, graph B, graph C, D, E, F, these are different graphs by twisting the characteristics. So right lead, left electrode, or central region on particular angle. You can twist it, and then you can add some doping, magnesium doping, N-type doping, P-type doping. You can include the doping and do some characteristics on these basis. So this kind of research you can perform, including some radius, on particular radius or particular temperature. If you are increasing the temperature, then how this device are behaving, that study can also be performed. This is diagram, that is multiple options are there. On once you will rotate it on different temperature or radius, how this changes will be done, that can be studies. So this tool not only simulate the material level, not only bend structure or some density of states. It can plot two terminal, three terminal, four terminal, even up to six terminal. Let's suppose left top of the electrode you have some contact, bottom of the electrode you have some contact, left side you have the contact, right side you have the contact, front and back side you have the contact. So top, bottom, left, right, front and back, up to six probe device can also be simulated. Here it is example of four terminal, but the user can also define up to six terminal as well. As you can see, the front and backs are not visible here, but it will also on particular angle. So this particular shape, plus shape, or particular rotate on your carbon nanotube or graphenes, you can plot the band structure, including the conductance. Conductance AC analysis can also be performed. So these are various four terminal device study for MOS2 based nano ribbon. Now we have the main competitor console and MATLAB. We have no competitor because that is not our main field. Our main competitor are quantum ATK, Gaussian, BAS, quantum X ratio. I can ensure you, I can promise you, this tool will be more better in terms of features as well. Some of them may be up and down with respect to quantum ATK only, but Gaussian cannot simulate the crystal structure. It cannot simulate the two-terminal device. It cannot simulate the three-terminal device. Even BAS can also not simulate the device quantum transport property. Quantum ATK, that is okay, but it is very costlier, and number of license is also not very much good as compared to that. This is a commercial tool, license version based tool, which need to be purchased by the universities. So your institute has to buy this kind of tool, but we can provide you the training where you can judge it, you can feel it. Either this tool will be helpful for your research to get to carry your to achieve your goal in this particular field. So quantum transport user interface is very easier. 6 probe is new feature. Bending the device structure, interface with Gaussian, Newcham, bars, quantum X ratio interface is also there. Crystal structure, input file, output file. You can import and export different file format, IV current, and transport spectrum. These are few of the advantage I have shown you with our competitor. There are so many other advantage could also be possible that I could not explain in the slides only. Now, I have explained about the NanoDCAL. That was basically DFT plus NEGF solver. Density functional theory plus non-equilibrium green function. NanoDCAL was DFT and NEGF solver for material and device calculations. But if you want to work on large scale DFT calculations, DFT and DFPT solver, there is another tool that we are representing from the same Nano Academic company. It is a simulator. Rescue, that is a background simulation engine. Another simulation engine that will DFT and DFPT, density functional theory and perturbation theory, that will use to calculate the optical properties, Raman properties, including hybrid functionals, meta GGA, and different LCO based optimizations is also there with Sten Homier and DFPT solvers are there. It is also written in MATLAB. Kohn-Sham theory is implemented to find the response functions, phonon polarization, phonon band structures, Kohn-Sham DFT and DFPT. So NanoDCAL can simulate 1000, 2000 based devices. But let's suppose you want to simulate 10,000 atom, 15,000 atom, 20,000 atom. So at material simulation only, this rescue cannot simulate the device. These are two different tools. One is called NanoDCAL, that is DFT NEGF for device calculation along with material as well, and rescue DFT and DFPT solver. DFT and DFPT solver for material simulation only, for response function, Raman property, optical property, large number of atom based calculation, including phonon calculation, hybrid functionals are there in this particular tool, dynamical matrix and dielectric tensor, band unfolding, charge analysis, nonlinear optical susceptibility, and large scale CFSI solver, phonon tool, spin effect for the material level, that is also possible. Both the software are supported on Windows operating system, Linux operating system, as well as Mac OS operating system. So it is OS independent tools. Any operating system you want to work, it will be fully supported on all operating system. So for large scale material calculation, many number of atoms only at material level you want to simulate, then this rescue will be helpful. Now we have this QTCAT tool, quantum technology, that is already released. Basically, slide is older one. This QTCAT is basically for quantum technology, spin qubit modeling tools for confinement of single electron to simulate the quantum dot in nanostructure semiconductor to find the envelope function of the electron and holes to simulate the cryogenic under cryogenic subkey temperature, charge stability diagram, Coulomb blockade, quantum transport, qubit simulator. Then this QTCAT, that is another tool from the same company. So for charge stability, FEM based simulation, finite element method based simulation. Then this QTCAT tool is there. For DFT calculation, NanoDCAL and Rescue tools are there. So Nano Academic Technology, basically the Canadian company that developed the commercial tool for simulate the material level simulation, large scale material simulation, NanoDCAL, DFT plus NEGF device simulation, and spin qubit semiconductor quantum technology device simulation tool that is called QTCAD. So it will also help you to find the spin qubit, FinFET, quantum device using the KP theory. Solve different solvers are there, quantum bell, quantum dot, charge stability, confinement of single electron and hole in nanostructures, semiconductor, then quantum TCAT tool will be helpful. So if we talk about the overview that we are representing, that is basically this impulse technology have many tools. In today's session, I have explored you this nano academic bottom one atomistics material and device quantum simulation tool. So I've explored you about NanoDCAL Rescue and QTCAT. Plus version of this NanoDCAL Rescue is under development basically in Python language. Since NanoDCAL and Rescue are in MATLAB language and plus version are in Python, where it may be fast, it is under development. In future, you may also feel this tool where it can be helpful for your research, including quantum technology. If anybody want to work on solar cell, one dimensional perovskite solar cell, tandem solar cell, thin film solar cells, LED devices, quantum solar cells, photovoltaic and OLED application with solar cell equipment, LED equipment as well as characterization. Then we have one another partner that is called Fluxim. It is basically for optoelectronics device simulation, solar cell and LED, electrical, optical, and emission property calculations. So this is all about the presentation session where I wanted to tell you that what you can do. Now in this next session, I will give you the overview of the user interface. What I can do, what you can do that I explained in the presentation. How it can be done, it will come in the next session. Then you can also do it by yourself, that the software that we have already provided, and also YouTube video we can also show you where you can watch it and learn it. Even after the program, you will have some problem, you can call us, you can email us, you can WhatsApp us. We have already created one group where you can post your questions in the group. We can help you, we can sort out the issue. Sometimes issue may be due to your current operating system, your network problem, or graphics problem. So license issues sometimes comes due to the existing computer configurations. So in any way, after this training program, we can also resolve their issue. Whatever your existing computer problems is there, we will try to sort out. This is my number. You can also call me, or you can call me in the person that you interacted with you, maybe Deepak or Ravikant. Anyone may be interacted with you. You can contact to keep in touch with them as well. So thank you for your good listening till then, and let's you can ask your query. If till now you have any questions also, you can also ask your question. Then we'll go for the I will open the software and show you the live session on the software. Then you can perform the training session in the second half. So you can also unmute your mic and please ask your query, and then we'll go for the next live demo sessions.
Can we able to find electromechanical property?
So in temperature effect or stress related modulus property is also possible. Modulus related things, thermoelectric Seebeck
Uh,
coefficient,
with,
it can be calculated. Yes.
with
Hello.
flexibility, electrical property may be changing, right? So can we able to measure that through this nano decay?
Your voice is not coming properly. Can you please ask once again?
Hello.
Yes.
Yeah, actually, my was with the flexibility, electrical property will be changing, right? So, can we able to like find how the property of my material is changing with respect to uh, stress, strain, and all, like electrical property basically.
Yes, definitely. Electrical IV current voltage characteristics, you can do the study. And once you will attend the same session, then you will learn a lot of options will be there, even for many other type of property as well. So stress, if you want to include some vacuum in your device, some stretch the cell, and then what will be the effect in your current voltage, that study can also be performed.
Okay.
Good morning, sir. My name is Simadri.
Yeah.
So I want to know that whether you can measure the electrical property like dielectric properties with polymer nanocomposites using this your software.
Basically, we have a dielectric option is also there where you can define some input parameter of dielectric. But rescue tool is there. In this rescue, maybe you can calculate the dielectric properties, some refractive index properties in this rescue tools. So we will understand your query in the detail, and then we will suggest you that either rescue or this nanodical, which one will be best fit for your needs. Okay, so we can learn, we can have a you can send your query in detail that what property dielectric you want to calculate, then we can have solution on particular that point.
Thank you, sir.
Hello, sir. Sir, can
Yes.
you hear me, sir? Sir, myself Santosh. Sir, if we synthesize new nanoparticles, Okay, using a chemical synthesis process, we will get some new novel nanoparticles with the different combinations, like nanocomposites actually, with ferrites, nickel, and copper, like that. So, how to feed the properties of that to the simulation tool, and how to study the properties, various properties.
Okay, let's suppose you have one graphene sheets. There is one graphene sheet, and on the top of that graphene sheet, you want to add one particular atom. Okay, that is as a nanoparticle. That particular atom you want to interact with that, and that study can also be performed. We will show you in the lab demo. If you want to add let on the particular sheet, you want to interact with particular one magnesium atom or any other material, you want to interact with that sheet, and how the characteristics will be changing with respect to that. That study can be done on the lab demo as well.
Sir, this synthesis of nanocomposites.
Basically, here you are simulating virtually. We are not doing anything experimentally. Based on theoretical models, theoretical equations, we will try to simulate here, and based on that simulation, we will try to expect that the that particular material, the property should be somehow near about that. On it may be around 90%, 92%, 95% accuracy you can predict it. It is not experimental thing. It is virtually you can do everything here.
Okay, sir, can we study the frequency response of magnetic properties, electrical and magnetic properties with respect to frequency?
Yeah, magnetic property is also there. Magnetic movement, textures, and other magnetic things are there. So in this demo session, we will also try to cover that, and even some of the property may be calculated by rescue. So we can also explore that for few minutes in the end of the session, so that you will be understand fully about that.
Okay, thank you, sir.
Yeah. So just try to concentrate these 2 days. In these 2 days, I hope many of the query will automatically resolve. Once you will fully attend this session, then many property may be resolved. Still, after these 2 days, you will have is unresolved. Then you can also come to us. We will help you.
Hi, sir.
Hello. Yes, please.
Hi. Hello. Sir, myself Onurupa Maiti. Sir,
Yes.
is it possible to make a surface from the crystal?
Can you repeat, please?
Is it possible to break a surface from the crystal? Suppose I want to create 110 plane from any crystal structure, suppose
Yep.
rhombohedral structure, then is it possible to break the only 110 plane from the
Yes, you can
surface?
simulate the rhombohedral, triclinic, tetraclinic, hexagonal, different lattice options are there. You can define their lattice parameter, alpha, beta,
No,
gamma,
sir.
ABC value,
Sir,
manipulate.
Actually, sir, if the crystal structure is there, I want to create particular one plane from the crystal structure, like 110 plane from the crystal structure. Then I want to adjust some atoms, such hydrogen atom, nitrogen atom on the surface. Is it possible
Yes,
from
it
this?
is possible. It is possible. We will show in the lab
Uh,
demo. We will show in the lab demo.
okay.
That is possible.
Oh, okay. Thank you.
Can we able to apply extra
Hello.
like parameters? Hello.
Yes, you can apply like electrical field and some
Magnetic field,
magnetic
like
field. I'm
for
not sure about that. I have to check it about magnetic field. I'm not sure. We'll check it, then only we'll be able to confirm.
and temperature,
Temperature,
like
electron temperature option is there. You can manipulate that electron temperature parameters.
okay.
Okay,
Yes,
actually,
please
I
carry
work
on.
on experimental software physics, so
Okay.
so I don't have any experience on simulation. So without having that, how this software, Nanotechnology software, will help in my research? I mean, just this is a very basic thing. I mean, to start with the Nanotechnology, what thing I should acquire in preliminary stage?
Yes, this tool will be help a lot. If you do not have experimental things, the software will help you a lot. Only simulation tool can also helpful to publish the paper. Experimentally is not a compulsory only, but if you have experimental facility, that is also better. But if you don't have, you can also simulate it, and you can publish your paper based on theoretical model, theoretical equation, theoretical calculation.
Actually, that is my question. Actually, I work on experimental physics. So to start, I mean, to
Okay.
work in this software, what kind of preliminary things I should acquire in the initial stage so that it will be easier for me to work in this software.
So you require some like coordinate points of particular atoms, and as well as some lattice parameter and length of ABC value, alpha, beta, gamma, that lattice types, and then how many atoms you want to simulate, and then theoretical DFT parameters is required. And if you talk about theory, I will also tell you that on what basis basically the software is calculating or predicting this output of particular material. So the basis equations, what basis the software is predicting this value, that theoretical equations or model, I will also explain you once I will start this session.
Okay. Okay. Maybe on hands-on training, it will be fruitful
Yes,
for
yes,
me.
yes.
Okay.
And even for
Okay. Thank you.
reliability of the results, we can have so many papers published where some of them maybe with the comparison with the experimental one or only theoretical simulation one. So many papers are there in good reputed journal that is already published by using this NanoDCAL tool on the Google Scholars. Once you will type it NanoDCAL, you will find a lot of papers are there. In this Google Scholar, you can see I type this NanoDCAL, so you can find a lot of papers are there. You can go down, there are so many pages are there on bottom. These are all 2000 this recent papers. So if you want to get this recent paper in 2023, you
Okay.
can see these are 2023 papers. These are
Okay.
all
Thank you.
latest papers, including if you want to more explore about it, you
Yeah.
can visit this nanoacademic.com. This is a URL. You can visit it and find some more details. I can show you here. This is nanoacademic.com, our principal. You can search this technical insight where technical papers are there. It is already there. By using the NanoDCAL software, QTCAD or Rescue tool, you can search from here. Sorry. 2022 and 23 paper is not updated on the website, but before that it is uploaded on Google Scholar. Recent updated papers are there. And once you will go down on the footer of the page, there is a forum, open forum is there, and documentation page is there. You can click on this documentation and tutorial, and this is a documentations. You can go to this NanoDCAL
Sir,
installation.
this is a 1 month license software for further procedure means for future application. What is the procedure for go ahead?
Then your institute has to purchase the software, so you can approach to your department, your higher authority, and they have to take the quotations and all purchase document from us. You can submit the document so that your institute can purchase the license for you. We have a multiple option: 1 year license, 3 year license, 5 year license, dependent on the requirement budget. We have a flexible policies, so you have to approach to your department where your institute has to buy this tool for you. This is a commercial one.
Okay, okay.
What is the cost for repairing a
So cost is dependent on number
subscription
of
level?
license, like one license, two license, five license. So let's suppose one license for 1 year, that will cost around 2.5 lakh something, and for 3 year you can expect around 5.5 lakh for 3 year, and around 7 to 8 lakhs you can expect around permanent license for 7 lakhs something near about that. So this is a theory page installation getting started. If you want to know the theory, that how this DFT is included in NanoDCAL with NEGF also. So this is theoretical model, theoretical equations. On what equations it is implemented? Hamiltonian equations, Coulomb theory equations, self-consistent, It will compute based on LCAO basic functions, linear combination of atomic orbital with Ks Hamiltonian equations. So these are all key point sampling, Ks equations, some theory parameter with their reference is also mentions, including
Hello, sir. Yes, I'm Askar Hussain from Peking University. I have a simple question regarding the software that you have told that it is also calculated the DFT calculation very easily. So, would you like to tell me about that? Which type of general approximations is going to use behind this framework?
it will use the LCAO linear combination of atomic orbital DFT calculations.
No, by the way, nowadays the meta GGA hybrid potentials and the PBE that are going to be using very rarely. Now, which type of general approximation is built behind this framework, which is usually used for its mechanical calculations and other calculations?
Okay, so let me tell you, in this NanoDCAL is basically use this LDA and GGA, basic functions, LDA and GGA. But if you want to use the meta GGA, hybrid functionals, PBE, correlations, then rescue tool is there, which will work on hybrid and meta GGA functions. So that's why I was telling you there are two module we have. If you want to work on hybrid or meta GGA functionals, then this rescue tool is there, which will use the hybrid and meta GGA calculation. In the demo session, we will explore you few little about this rescue tool as well.
Sir,
Where
this
you,
is like VASP software, right?
yes, you can tell it. It is like VASP.
Mm, mm,
Rescue is like VASP. NanoDCAL is like quantum ATK. You can say like that.
Oh, thank you. And by
But
the
this
way,
rescue can perform DFT calculation, perturbation theory, Raman optical, maybe not in present in the BAS, I'm not sure, but it is basically for perturbation theory is also included. And rescue price will be lesser than that NanoDCAL. And we have a YouTube channel also. So if you want to watch the video that we have presented in past, these are our past organized video channel on rescue nanodecal. So just follow, type impulse technology innovative research in your YouTube channel. Once you will type it, you will find our channel Impulse Technology Innovative Research, where you can find a lot of videos are there, including the optical property, Raman property, Onon spectrum, thermoelectric, module of elasticity, Humolumo transport property, Graphene effective mass calculation, transmission coefficient, spin orbit coupling in linear combination, tunnel magnetic junctions, including molecular junction. These are all videos are already posted. So even today's end of the day, you can also watch, and maybe it will be very helpful. This video library.
So, in India, like you have said, like in institute only we can able to provide software, right? So in India, what are institute you have provided this software, like NanoDCAL software till now?
We have provided to NIT Mizoram, IIIT Allahabad, NIT Uttarakhand, Thabar University Patiala, MS Ramaiah University Bangalore, and some other is already, so many other are already in pipeline. So around 10 P Sastra University, Tanjavur, Tamil Nadu, and many more other are there.
Okay.
And for rescue, it is also used by IIT Indore and ICR Behrampur, IIT Bangalore.
Sir, did you provide in any IJAR?
Sorry, what did you say?
In IJAR you provided previously?
Yes, IICR Kolkata.
Yes, I am telling from now.
Yeah.
Sir,
Can
did you
please?
provide in IJAR Kolkata previously?
Yeah, we have provided this rescue software in IICR Kolkata. So I think we should go for the live session. Okay. So many of your doubt will be cleared. If any issues are there, we can also take your query after this training session as well, after end of the day also. So So ISC there is nobody is using currently, but we are planning to target some customers. Still, there is no one in ISC Bangalore. So let me start the software. So I want to open my device studio user interface. So just a minute. So maybe wherever the software you are installed, the hands-on training you can do in the second half. First half, just try to concentrate on the demo part so that you will be know about that what this software can do. Still, the software you already have, that implementation or execution part you can do later on. But just try to concentrate here. So it is installed in my C drive where Device Studio 2022A 2023 version is about to release within a month, where you can also install on Linux version as well. So I want to click on skip login, and this is my 1 minute. Now you can see here, this is a C drive where my software is installed. So in this Device Studio 2022A version, Device Studio is basically a user interface to modeling the structures. If I click on this bin folder, under bin folder there is a executable file, application exe file, Device Studio. It is an interface to model the structure, graphical user interface for modeling. It is from same company. I click on skip login, and here I want to start from scratch. So I click on create new or open existing project. If you already working on that, you can open existing project or you can create the new project. Click on OK. I want to start from beginning, so I want to click on this and click on new button. Now here I want to define the name of my projects. Let's suppose training is the name of my projects. I will click on save button to save it. Just a minute. NanoDCAL training. There is training folder already presented on desktop. That's why. Now I have created NanoDCAL training folder. Now this is my user interface. And you can see here, NanoDCAL is already available. NanoDCAL and Rescue. Both are available. These are simulation engine. Okay. So main is called NanoDCAL and Rescue. Device Studio is only the interface for modeling the structure, so that you have no need to write the code, no need to write the script, or understand the script will not be compulsory. By single click, you can create multiple structures. So this is a window where you can see the top bar, file option, edit option, view option, builder is there to build your structure as per the desired shape. So you can build your structure. You can see there are so many options will be there. Some of them are hide right now, but once we load the material, it will get enabled. And this is simulator where we can run the calculations, and other help option will also be there. Top of that, there is some build toolbar is there. This toolbar option will be enabled once I will create or load the material. Middle of the screen basically visualize your structures. Whatever kind of structure you will create, that will show in middle of this regions. Left side is called project. This is called project. NanoDCAL training is the name of my project. So input file, output file will be shown here. In this particular region, it will show the input file and output file. And bottom one is called the property, which will show the material property. Property in the sense like your crystal lattice parameter, coordinate points, number of atom. These all will be explained. So this property tab will basically define the crystal informations, material device information, and bottom one is called job manager, that will execute your task. Whatever your program will run, that program status will show in the bottom of the page. Manipulation in your structure will be done from top of the page. Now I want to start from the beginning. So I will click on the file option and click on the, either I can create my new project I already created in the beginning. NanoDCAL training was the name of my project, and this is your open project. If you already have the existing project, you can also open it, save it, new, or you can import it, and there are other options are there. you can see there are two options, new one and import one. New one in the sense, let's suppose you want to create your new crystal, you want to create your new molecule, you want to create your new device. You don't have any information, you don't have any material files. As an example, some of the person may be working on BAS, or you may be working on quantum ATK, you may be working on quantum XPSU, and you already have some material file that may be in CIF format, XYZ format, or even postcard format, or any format. If you have that option, then you can simply click on import local, where you can browse your existing file, you can directly load in the softwares. Instead of creating the material from the new option, you can load your existing material in our device studio. That will save, so that you will not have to create the material from the beginning. That's why this import option is there, so that you can browse your existing material. There is a online option is also there. If you want to load the material from open source material library, open source material library in the sense, crystallographic open source library, COD, crystallographic open material database, material projects open source library, and some other library. From there it can also fetch the material online. There are two things. One thing is that you already have the material file in XYZ, CIF, or any other file in any other format. Second option, you can directly import from this online search. Let me click on import local. Local in the sense, in your particular computer, in your particular location where the file is located. In this software, there is some material library already provided as an example. Some of them material are already present. Some zero dimension molecule, amorphous molecule, polystyrene, polyethylene, polypropylene, amorphous related molecule, including the crystalline related molecule. These are all molecule library. Zero dimensional materials are there. Some terylene, some alcohol, or some rubber, xylene, or nylon, ketone, whatever the polymer you want to use it. As an example, some of the material are present in XYZ format. But if you can see here, this is a bottom one, HZW, XYZ, CIF, XSD, postcard file, scf.input, relax.json, aimd.json, AS, .mol file, and other extensions. So these all extension .php, these extension, if you already have that file, directly upload instead of create it. Now other material is also present. You can see this is a one dimensional material library, one dimensional carbon nanotube with different chiral vectors, armchair, zigzag, n and m value, 5 cross 5, 6 cross 5, whatever the carbon nanotube, armchair or zigzag, you can select that 1D material. So once you will select it, it will directly load it. Like I have loaded one chain of carbon nanotube from my library. You can see here, I can also repeat it 15 times, 20 times in Z direction, C direction, to repeat multiple times. Same unit can be repeated by single click. Okay. Similarly, I wanted to show you first of all the material library that present in our database. So zero dimensional, one dimensional, two dimensional, graphene, axene material, nobility material, black phosphorus, hexagonal, boron nitride, arsenide, bismuth, and some three-dimensional material, conductor, insulator, layered material, magnetic material, metal oxide material, nobility material, semiconductor material. These are all library of the material. From that library, whatever material you want to choose, you can pick that material. These are all conductor, pure metallic library. So HZW is the unique format of this particular software. But other format is also supported, where you can upload directly on the tool. And insulator is also there. Diamond, NSGL, and magnetic material is also there. These are some Fe related and MnSV, ZnO, FeO. These are the magnetic, and metal oxide is also there, including the nobility material like perovskite, topological insulators. So these are different perovskite with different combination. It is also presents. So whatever you want to simulate, you can pick that particular material. It will get it load. It will directly load it. Okay. As an example, I have loaded it. You can zoom particular atom and then you can perform this study. Now, what I have did, I basically imported the material from my existing library. You can see here it is already imported. Now there are some other option is there. Let's suppose you don't want to import from the library. This is a new option. You can create your new crystal by defining your lattice parameter. You can create your new molecule or new devices. If you want to create crystal, this is a crystal builder user interface, where you can see in this particular crystal builder you can find different space group: 1p1, 2p1, 3p2, 4p21, 5c2, 6pm, 7pc. There are multiple options are there. Once you will select it, Bravius lattice, it is a cubic case centered. Only a lattice parameter is enabled. So dependent on the space group, the parameter particular parameter will be selected. Like you can see, I have selected 193 P63, where A and C is enabled, hexagonal is elected. We have to define the P1, P2, P3 that are fractional coordinate. So I will click on this button and define the coordinate point. These are the fractional coordinate point. I selected it. By default, it is a carbon element. But if you want to choose any element from the periodic table, just click on this carbon atom. Default is carbon, but double click on the carbon, you will find the periodic table where whatever the element, whatever the material, whatever the crystal you want to create, by defining the multiple atom, you can select the desired atom from this units. So if you want to take silicon, you can click on silicon. Silicon is selected element. Click on OK. Similarly, then click on plus atom. Then again define this coordinate points. Silicon is selected. If you want to use anything, it can be used like that. Click on primitive cell, conventional cell. See the preview. This is a preview. So crystal structure, you can build any type. As an example, I have taken it. There are multiple space groups are defined. So whatever space group you will select, it will take accordingly. So triclinic or the option tetragonal, it is a tetragonal. You can also change the A value and C value. It is editable value. User can define their own value. Whatever the value you want to define, it is up to you. So user is a full flexibility where the desired shape, the atoms can be created. So you can define like that the particular points. Let's suppose you want to edit these points. These are the editable points. You can edit, define the coordinate point, fractional coordinate points as per the required things, and see the preview before you build any crystal. You can visualize it, then you can build it. So make sure your crystal is created properly to build it. If you want to create only 2 atom, 15 atom, 20 atom, n number of atoms you can create, and then click on build the atom. It will create that particular structure in this particular dashboard. As an example, it is done there, but how properly you can define your exact coordinate points, once you will put your own input parameter, software can quickly create particular desired structures like it is created in this particular examples. So in this particular perovskite material, you can see this is a property tab bar. This nanodical training, this project will basically describe the input file, and once you run the job, then output file will also come in this particular area. This particular area is basically for input file, output file. Below area is basically for property bar, where it will describe, explain the coordinate point, number of atom, and the lattice area, the total unit cell, that is explained here. So you can hear the coordinate points of this particular atom, x by z coordinate point, total number of atom in this particular unit, and total area. If you will click on particular atom, let's suppose you want to select it, you can click on this arrow button and select the atom. So this yellow atom is selected. Once this yellow atom is selected, it will display the element name and their coordinate points. Now, if you want to, you can right click and select it, draw the rectangle to select all the atom. So by yellow color, all atoms are selected. I can right click and click on display atom. So display atom will show the all information of the element, how many atoms are there in this particular structure, and what is the coordinate point. So you can see here there are 20 atoms are there. Some of them are this element oxygen, magnesium, and this La option is there, and their coordinate points. So that's why each coordinate point you can also export your element information. Click on export button, and this file is automatically exported, where you can see this data of your each element coordinate options. So I hope it is clear. I can right click and I can click on display style, or I can give the labeling and other informations. Now you can see here these are the number of atom can also be display, how many atoms are there, the number of atom you can visualize like that, and which atom particular atom numbering is mentioned, so that you have no need to count the particular atom. Atomic numbering is there as well. If you want to clear the annotation, you can click on this home button to go there, and you can also clear the annotation. Anyway, so this is atom. Now if you want to simulate any material, okay, you want to simulate any material, or you want to do any manipulations, let's suppose I want to use any other material, so I can go to the import, and I can go to 2D material and take any other material. Okay, so top bar you can see here, this is a top bar, top toolbar. This toolbar will help you to create a multiple options. Okay, you can select particular atom, you can rotate, you can zoom in, zoom out. But as an example, in the first go, as a beginner, as a layman, let's suppose you want to simulate single two atom graphene. We will convert into the sheet later on. First of all, let it simulate a single two atom crystal. Then we'll go for the advanced features. Software will be very huge. This 2 days you will understand a lot of things. So I will go to the simulator option. This is simulator, and go to this NanoDCAL, and I will perform the SCF calculations. This is SCF calculation, self-consistent field calculation. In this particular things, you can see here electron temperature. Default is 300, but if you want to put it 313 or any temperature, you can define the temperature range. This is energy cutoff, whatever the energy cutoff value. Now, as you were asking about the action correlations, here the LDA and GGA with PVE functionals are mentioned in this NanoDCAL. But for meta GGA, hybrid functionals, PVE 06, then rescue tool will be helpful. This is for device calculations. Here I can define the k point sampling, number of sampling point in n1, n2, and n3 direction. And this is iteration control. It will solve the Hamiltonian equations, density matrix, total energy, maximum steps, mixed ray method, linear, quadratic, Brodmann, GR Pulley, multi-secant. These are the multiple options. So mixed rate, mixed method, Hamiltonian mixing, density matrix, real space method, it will use it. This is basis sets where you can also use the U terms, LDA plus U. So by default, double zeta polarized, PBE, LDA, double zeta polarized basis sets are there, but user defined basis sets is also supported. So I can show you the library of basis sets, user defined basis set, that is neutral atomic database. This is basis sets library. Whatever the material are used, you can choose the double zeta polarized, single zeta polarized, that basis sets library. For all material, this is the library for in a periodic table, whatever the material are there, for that material, you can choose the particular material from this the library. You can see here, mostly, even not only mostly, all material basis sets are included. From that basis sets you can pick up that particular basis sets, so either using silicon, carbon, or anything, LD type and PBE type. So this is a carbon double zeta polarized basis sets. Even some other general basis sets library also there. This is a double zeta polarized, single zeta polarized, with LDA type, PBE type, for each material from the periodic table. This is a library for basis sets. Then next option, it is goes to the spin type, where you can define the collinear spin, general spin, non-collinear spin, type of spin, transport calculations. So if you want to include the spin effect, spin orbit interaction, polarizations, then you have to enable this collinear spin, where you have to define the rho spin polarization. For general spin, spin orbit interaction, rho theta phi, you have to select this general spin option. For spin related effect, initially I want to simulate without any effect, so I click on this generate file. I click on this generate file option. Now once I click on it, in this left side under Graphene, scf.input file is generated. You can see here scf.input file. Now I can right click and click on run button. If you want to check the script, that coding behind that, then you can click on open with. But if you want to run directly this graphene two atoms crystal, then directly click on run button. But before that, if you want to check the script coding behind that, you can click on open with. It will open the script generated automatically from the user interface. So you can see here, this is automatically generated script. Now you can see the whatever the default parameter are mentioned in SCF input parameter and the coordinate point of the crystal. Accordingly, since this is very two atom are there, that's why this coordinate point of two atom are explained. With minimum atom iteration control, flags are there. With vector flags are there. Basing settings flags are there. It is very small crystals. But once we will go for the advanced level, it may take some time, but definitely it will easy to understand quickly. Even you can also change in this particular script also. But writing the script may be a chance to get the error. That's why we prefer to use the graphical user interface. I will right click to run the directly program. I click on this run button. Once I will click on run, this gateway is opened where I can run the job in parallel also. Since this training license is basically a serial license where it is just only to educate you about this tool, that how this tool can benefit for your research. But once you will purchase it, we will provide you the parallel license. Parallel license in the sense where suppose you have a good workstation, good cluster, where many number of cores are there in your hardware configuration. As much as your hardware is good, you will get a faster calculation speed. But this trial version is just only to run single core. You will not get faster speed. For faster speed, you have to buy the license. So you can see here, this is run parallel. Either let's suppose in my computer there are 8 core are there, but whenever you have, let's suppose, 32 core, 64 core, 128 core, you can run the job on multiple core. It will get faster results. As you know, or maybe not we know, but I can tell you the density functional theory and NEGF takes some time to simulate the crystal material or devices. Once the number of atoms are increases, then the simulation time will also be increases. If you want to run on 5 core, you can select the number of core and click on run button. Once I will click on this run button, in this bottom of the page the script will enable. You can see here this tab, the path of the particular script with their status, either it is running or stopped or terminated. The status of your calculation, it is running here, that you can see. We will increase the number of atom one by one. We will go from the basic level to the advanced level. That's why it is a complete 2 days training. So please be patient, stay with us. We will help you out to boost your research. Now, in the meantime, the simulation is running. I want to select my analysis. What kind of property you want to calculate. So, even parallelly, the calculation is also finished. Now, once the calculation is finished, or even if it is not finished, also, you can select the analysis type. What kind of property you want to predict. Hands-on training you can do in the second half. Initially, participants just concentrate on the demo so that you will have a complete idea about the tool. License is already provided for 1 month where you can do the practice. But before that, this live training is very important for you. Now, this is the analysis window. What kind of analysis software can do? It can calculate the density of state, effective potential, total energy, band structure, charge, assign, phonon band structure, electron density, potential, transmission channel, eigenstates, full band structure, effective mass, complex band structure, ZT, phonon band structure, phonon density of state, phonon transmission channel, etc. So these all things you can do that. So I will select, let's suppose, band structure. I selected this band structure, and this band structure selected. Out of all analysis, initially only band structure I have selected. You can see symmetry K point, G M K G A L H A. These are the Brilliant Jones root point default with number of K points 100. If you want to check the path, you can click on this path button. Once you click on this path button, you can find the Billion Jones window. This Billion Jones path point, you can see these are different options are there, and here you can see that options. You can add, you can see this plus button where you can choose, you can delete particular, or you can create a new Brilliant Zone path, or you can delete particular Brilliant Zones path as well. You can rotate this. This is Brilliant Zones for band structures, and apply it. Similarly, if you want to plot the electron density, you can select it. You want to the potential, select it. If you want to see the effective mass, or you want to see the total energy, if you want to see the effective potential, or you want to see this Harty potential, exchange correlation potential, neutral atomic potential, transmission channels, and eigenstates, these all you can select it and click on generate file. I click on this generate file. Now you can see here this input file. You can see this input file project window. In the project window, once your calculation for SCF input file is done, you can check your calculation text file of your simulation window. This is a text file of your script where it is run the job, how much time it took to generate the calculate the output. Now I have selected these analysis. So I band structure dot input, electron density dot input, potential dot input, total energy, effective potential, transmission, eigenstate. I will right click and run the program. Similarly, I will select all and put it into the queue, my all input file. Right click and run it in the queue. Right click and run it in the queue. Right click and run it in the queue. As you can see here, I am putting in my queue so that one by one automatically it will get start. It is not like that once one will finish, then again after a period of time I will start it. You can see here this is finishing and rest of them are in queue. So one by one it is finishing and generating the output. You can see here this project tab window where band structure dot output file is generated. I can right click and click on show view. This is a band structure that is generated with William-Jones root point path. So from there you can find the direct indirect band gap. You can also export your data. This is export button. You can click on this export and save this data in the form of PNG file, JPG file, BMP file, PDF file, text file. These format the data can be shipped. And if you want to save on desktop in the image format, click on save button. Similarly, if you want to save in the form of text, you can select the text format and click on this desktop or anywhere, any location, and click on save button. Data will be saved on the desktop in the form of image and text. So you can see here the why I have taken two atom crystal because it simulates quickly. If I will increase the number of atom, the simulation time will also increases. As you know, it is a computational software where it required the good system, but 2050 atom will not be 100 atom will not be required so much of time if you have good server. Now similarly, I can right click on this electron density. This is electron density, total electron density. This is total electron density in three-dimensional plot. For two atom, we will increase the number of atom one by one. And this is a two-dimensional plot. Two-dimensional plot along x-axis, average along x-axis, along y-axis. This is along y-axis. This is along z-axis. So any direction, x-axis, y-axis, z-axis, plane display, and stereoscopic display. These are the type of display with 3D plot, 2D plot. It can be plotted. Whatever line plot and other, it can be plotted and inverted as well. And similarly, the one dimensional plot along xyz plane, along yz plane, or along xz plane. So 1D, 2D, 3D, whatever the plot you want to do it, it can be done accordingly. Now, next is called Coulomb potential. So I will right click and this is a Coulomb potential. In 3D plot, you can visualize in XY view, YZ view, ZX view, whatever the view you want to visualize, it can be visualized like that. So 3D plot, similarly Coulomb potential in 2D and Coulomb potential in one dimensionals. So one dimensional, two dimensional, XY, YZ, whatever the plane you want to see it, it can be visualized on that particular planes. And if you want to see the transmission spectrum, this is a transmission, not a spectrum, number of transverse channel along average k space with energy range. So transmission spectrum will be for device region, and this is eigenstate If you want to see the eigenstate, band value, eigenband value is also there, and two-dimensional plot for the eigenstates in x and y axis and z axis, and similarly for one-dimensional plot in any of the plane. And similarly you can also export this graph as well in that particular image format. So the graph can be exported in these format. This is option is also there. So 2D plot and 3D graph, all things you can also export to take your data. So this three-dimensional, two-dimensional, as well as one-dimensional visualization output can be exported. So this is two atom that I have taken it, and I try to simulate and show you few characteristics. We'll go into the details since we have a lot of time, so we can educate you one by one. Now, let's suppose you want to repeat these structures. Okay, this is a builder option is there. You can see there are so many options are there. Molecule 2D decomposition, device, convert to device, interface builder, crystal, redefine crystal, crystal geometry, nano ribbon, nanotube, even for surface plane nanowire, this will also be enabled. Convert your existing PY file, some other software file can also be converted and import here. I want to click on redefine crystal. This crystal I want to define again. I want to repeat, let's suppose 5 times in the vertical direction, that is B direction. I want to repeat 5 times. Similarly, 6 times or 4 times I want to repeat in A direction, that is called G direction. So you can see here I have repeated it 5 times and 4 times. If you want to increase the number of times, let's suppose in B direction you want to mention this 8 times. So I can click on this. It is 8 times repeated in V direction. If you want to take this one as a 6 times A, you can repeat in 6 times in C. If you want to take twice layer, you can also repeat 2 times in the C direction. So 2 layer can be taken. So dependent on the type of the structure you want to create, you can create the desired structure as per the needs. So either you can take only one in C direction, you can type one, see the preview before you build the final structures. So I click on initially take it one, click on build button. Now I have taken this build button. This is one sheets where I have repeated the same structures. You can also zoom it. Say zoom single layer, bi-layer, tri-layer, mono-layer, or whatever the number of layer. As a, it is only carbon atom. We will try to create the structural defect or multiple other type of defect will be created. That's why this tool option will be there that will enable you to help it. If you want to measure the distance in between two atom, any two atom, this is a right side distance measurement tool is there. You can click on one atom and then another atom. It will measure the distance from center to center. So from center to center 2.842. This is one atom to another atom. Angstrom. Angstrom is the unit. The distance is calculated. So between two any atom, if you want to measure the length of your channel, similarly the same procedure. Left side to right side, you can measure the length of your device. Similarly, if you want to measure the angle, this is the angle measurements. So let's suppose you want to measure the angle in between three atom. So what I can do here, let's suppose you want to measure the angle of these three atoms. You can see the 60-degree angle in these three atoms. Okay, so angle measurement, length measurement, even dihedral dihedral angle, that is plane to plane. Like in laptop, there is a vertical and horizontal. There are two planes are there. So plane to plane dihedral can also be measured. In upper desktop and keyboard, there is one vertical, one horizontal. So that kind of plane, if you have want to measure, that plane can be measurement. Vector measurement can also be done. Vector between two elements, that can also be measurement. And other option is also there. You can convert this crystal into the molecule. So let me go to the back condition and see our main direction. So if you want to create the defect, then what you can do, let's suppose you want to create the defect. If you want to do the undo, anything happen by mistakes, you can, this undo option will also be enabled. So let's suppose you want to create the defect. This is an atom that I have selected. It is a carbon atom. If you want to create a defect, you can click on this delete button. This is delete button. You can click on it. The atom has deleted, and that defect is created in this particular single layer. So this defect can be created, that you can see the atom is not there. If anything happen by mistake, you can also undo it, so that you can make the changes as per need. It can save lot of your time, so that you can concentrate, you can focus on your research goal, instead of writing the code or investing your time in such kind of things. That's why these kind of innovative tool will help you to focus or measure many number of time saving and paper publication useful. If you want to replace the atoms, either let's suppose this atom you want to replace it, you can click on this replace atom button. This is a replace atom. In the replace atom, periodic table will be opened. Let's suppose you want to add the doping. You want to add the doping of magnesium or any atom, zinc, whatever atom you want to dope, you can select it and click on open. It is now, you can see here, the color of the particular atom has been changed. It is a doped atom. It is a different magnesium doping atom. How get to know the which atom it is? Once you will click on it, in this left side of the property tab, it is displaying, it is a magnesium element with their coordinate points. If I click on this one, it is a carbon elements. So this kind of things can be done. If you want to change the bond length in between two atom, just select that particular two atom, click on this edit atom with selected. This is a bond length. Bond length as you desired, it can be created. Let's suppose there is one another element and second one is another element. If you want to define the bond length in between two elements, it can be adjusted. This is a editable value. Whatever the distance you want to keep. So magnesium and carbon I have selected accordingly. Whatever, if I want to edit this bond length value, I can change manually. Similarly, there are other options are there. If you want to move the atom, this is the move atom in plus x direction, plus y direction, minus x direction, minus y direction, g direction. So you can see here how the atoms are moving. I click on plus g and minus g. So accordingly the atom can be movement. Plus x, minus x, or whatever the movement position I want to do it. It's dependent on me in which particular direction I want to move it. So these kind of rotation or movement of the atom can be done to change the positions. Similarly, if you want to rotate it, instead of moving, you want to move the clockwise, anti-clockwise, 30-degree angle, 40-degree angle, 50-degree angle. These are all rotation. So you can see here by screen vector along x y z axis vector along abc vector, you can rotate it. So this is like rotation. Here you can rotate the selected atom. If you want to select whole, you can also rotate particular that particular atom, or that particular angle is also specified. Okay, so this is basically a rotation the user can perform as per the desired need. Similarly, if you want to create the mirror, let's suppose there is a left electrode, right electrode are same. top and bottom electrode is same. So you can also create the mirror. This is a mirror structure. The mirror can be created. I am explaining you about the interface, how it can be helpful. If you want to create the stretch, you want to stretch the cell, you want to define some strain vector. This is strain stretching is also there, that can be performed. So this is basically for stretching the cell, or you can change alternate the axis ABC, alternate the coordinates, or even it can wrapping option is there. You can wrap the particular atom. You can see the wrapping can also be done, or you can also perform this center position. So you can fit the cell to remove the vacuum. We can create the vacuum inside the cell. We can remove the vacuum inside the cell. Dependent on our need, we can do that particular task. So this is one seed. If you want to go to this crystal, you can click on this crystal. You can see here the different type of previous lattice are there. Simple cubic, face centered, body central, rhombohedral, hexagonal, tetragonal, simple cubic, body central, orthorhombic, monoclinic, triclinic. Even user defined option is there with their ABC value primitive vectors. These are the primitive vector ABC value. The user have to include the vacuum space accordingly. Like let's suppose I want to change this A value, so I can change this A. So you can see here the in the A direction some vacuum space has added. If I want to add more vacuum space in A, I can add, let's suppose I have done 35. So in this particular A direction, it is added. The vacuum has been created in this particular regions. And then I can click on center. This is center button. So this will be there in the center positions. Now you can see here, there is an option called surface slab. If you want to create the surface, this is surface slab position. You can create the 111 plane, 100 plane, 110 plane, whatever the plane you want to create the surface. You can also create the surface structures, and their element will also be there. This is surface slab, vacuum thickness. You can create your desired needs. Okay, so let me take this crystal first. 1 minute. If you want to create the surface, this is a builder, redefine 4 to 5 and preview and then build it. And then you can go to the surface slab. You can select this surface and you can click on build button. It will create the surface slab, and go to this center. It will create in the central region, and then you can simulate it. So this is just overview about the tool. Okay, now I want to also explore you some other features. If you want to create the graphene nanoribbon, click on this graphene nanoribbon. Define the unit cell of graphene nanoribbon by the Kral vector. Carbon waste or boron waste, you can select the site A, site B. This is multiple options. So multiple options are there. Select from the periodic table, boron waste or whatever. Define the bond length in between the atom. Passivate with a dangling bond hydrogen atom, and you can select the number of armchair, zigzag, armchair type of graphene nanoribbon. I define this type. Hydrogen passivated graphene nanoribbon is created in the builded. That you can see here. Within a few seconds, you can create so many number of atoms waste material. Similarly, the nanotube is also there, where you can uh, create the nanotube. Just a minute. If you want to build the nanotube, go to the graphene nanotube, and here you can define this circular nanotube options. This is armchair. Define it and click on build. So one inside another, multi-bollet, single bollet, carbon nanotube can also be created. You can include the doping, defect, all those things. And you can see here the total number of atom, total area of this whole lattice that is explained. Now you can see here there are so many other options are there. It will help you to create the molecule and other positions. And then we'll go to the device simulation. For electrical device calculation part will be covered up by tomorrow, but in the hands-on session my colleague Bill Deepak Upadhyay, he will explain you about the next training session in the second half session. So till now I think it is a good enough to learn the interface about this device studio. Repeat it.
Can you repeat once again how to change bond length and bond angle?
Okay, so for changing the bond length, just simply select that atom. Let's suppose these are two atom. Okay, so go to this arrow button to select it, and then left hold the left button and draw the rectangle, or you can press the control button and click on one atom, then click on another atom. Hold the control button, click on one atom, then another atom. Then this is an option called edit atom with selected. You can here see this is a bond length. You can change this value. It is a editable value. Let's suppose if you want to edit 1.5 something, anything you can mention this value in this bond length changing option. I hope it is clear.
Okay, okay, clear, sir. Or bond angle, sir. Once again, can you show
Sorry.
bond angles?
For measuring the angle, there is an option. Let me tell you. This is one sheet. You want to measure the angle. So I can zoom it. I can hold the left button and then move the cursor. Hold the left button, move the cursor. Now I want to measure the angle. So in this top right side, there is angle option is there. I can click on it, then press Control and select any three atom where you want to measure the angle. Select any three angle, and you can also select on this zoom button and then move it by hold the left button and move the cursor. Hold the left button and move the cursor. Got
Okay,
it?
sir. Or for sir, or deleting any atom, sir. Can you repeat once again?
Sorry.
For deleting any atom.
For deleting any atom, just select that particular atom and press this delete button. Even from the keyboard also you can also delete. On the keyboard there is a delete option is there. You can select that particular atom and press delete button from your keyboard, or you can click on this delete atom on the top side.
Uh, Excuse me, sir. Hello, sir.
Yes, yes.
Thank you so much for a beautiful and wonderful session, and plenty of knowledge from your presentation. And my question is that in for any of structure or for any of DFT calculation, the first step will always be the stability step. So in order to check the stability of a structure, is there any option in this software?
Actually, in middle of that, your voice was disconnected. So can you please ask once again?
That box, that one box, three-dimension box was that, right? So what that box indicate basically?
So three-dimension box is basically a lattice. That is why it's lattice. The box was the crystal lattice.
Okay.
So now, like whenever we are generating or simulating for a particular material, so you were trying to input some parameters. So when we are actually importing for a particular material, whatever the data that we get from importing are the original materials, or we should know them in prior, but how do we get those material information?
So basically, there are two things. We have a material library, okay, that you have to use that existing material and find at what which material is better to get your characteristics. There are so many open source library like material projects, crystallographic open source database where some materials are already available and their input parameters are explained given, like lattice parameters are already there. So that material you have to upload or you have to create, but at least some input you should know it. You should have some input parameter for each material. Either you can use the existing material or you can do by your own research by putting some input or changing some input of your material input parameters like lattice, bond lengths, and some alpha, beta, gamma, ABC. These all things you should know it, and then only you will be able to simulate it.
Okay.
So at 2 p.m., just please come back again. My colleague Deepak Upadhyay, another speaker, is there. He will explain many of the things. You can also ask your questions to him as well. Maybe some of them he can answer you. Okay, and you can also open your software. You can try to use this tool even beyond this training session. We can also help you, and we'll work together to achieve the research goal, whatever you want to achieve. So thank you once again.